What is the parametric form? Well, parametric form is when you give the coordinates of a vector. If you give the coordinates of a vector in terms of a parameter, okay, in terms of a parameter. And Cartesian equations of a line means, the equations that we normally use to mention different lines in Cartesian thing. So here, since we are talking about a three-dimensional model, now we need three equations. Okay, so let's start with parametric form. Okay, so let's start. If we have to learn about parametric form, we should start with vector equation, as that's the way we are using to represent a line for now. Okay, so we have the vector equation of a line. So let's say let let vector equation let vector equation of line L be R is equals to A plus lambda B. Okay, so here we know R represents the line, and A is a point on the line, which is the position vector, and B is the direction vector. And lambda can be any real number. Lambda can be any real number, positive, negative, zero, doesn't matter. Lambda can be any real number, and that will represent, that is a real number that will multiply. It will multiply the vector scalarly. Okay, so it will increase the scalar value, the magnitude of the vector B. Okay, so let's now jump into parametric form. Okay, so let's say A is equals to XYZ. Okay, not XYZ. Let's say A is equals to X naught, Y naught, Z naught. Okay, so we know A is a vector, and let's say that is equals to X naught, Y naught, Z naught. Okay, and let's say B is equals to L M N. Okay, let's say B is equals to L M N. All right, so now let's say R is equals to X Y Z. Okay, so X represents the X coordinate of the vector R, Y represents the Y coordinate of the vector R, Z represents the Z coordinate of vector R. All right, so how can I convert this vector equation into the parametric form? Well, first of all, let's write this down. Okay, so we have X, Y, Z is equals to X naught, Y naught, Z naught, or you can say X0, Y0, Z0 plus lambda L M N. All right. Now, since this is vector operation, I can simplify this side. Yeah. So I will have X0, Y0, Z0 plus lambda L, lambda M, lambda N. Once I add these two, I will get X0 plus lambda M, Y0 plus lambda M, and Z0 plus lambda N. Okay, well, this is lambda L. This is lambda L. Okay, but what is this equals to? Well, this is equals to X, Y, Z, the X, Y, Z coordinate of vector R. So, by using this, I can say X is equals to X0 plus lambda L. Similarly, I can say Y is equals to Y0 plus lambda L. And also I can say Z is equals to Z0 plus lambda L. So this is the parametric equations, the parametric form of a straight line. This is the parametric form of a straight line. Okay, I hope you understood. So I will give an example so that you can actually practice this to understand more clearly. Okay, more clearly. Now let's see an example. Let's say R is equals to 1, 2, 3, plus lambda 4, 5, 6. Well, I can say if they ask you the parametric equation, write down the parametric equation. If you want to write down the parametric equation, well, it's very simple. Y r can be equals to x by z. Yeah, r can be equals to x by z. So we can say the parametric form of the vector equation given here will be x equals to 1 plus 4 lambda and y is equals to 2 plus 5 lambda. Okay, and let's say z is equals to 3 plus 6 lambda. Okay, z is equals to 3 plus 6 lambda. We can use this to make sure if a point, if a point is present on a line or not. Okay, so we can use this to make sure if a point is on the line or not. Okay, so let's say this is the line, okay, that is represented by r is equals to 1, 2, 3 plus lambda 4, 5, 6. Okay, so that is given in the parametric form. X is equals to 1 plus 4 lambda, y is equals to 2 plus 5, 5 lambda, z is equals to 3 plus 6 lambda. Okay, so let's say this is given to us. All right, now let's try a simple question. Okay, let's try a simple question like this. Let's say they are saying, okay, so the x coordinate of the point, let's say there is a point, let's say there is a point P, okay, the x coordinate is equals to 5, y coordinate is equals to 7, and z coordinate is equals to 9. Okay, that's what they are saying. All right, so they are asking us to verify whether point P is on, let's say this line is capital L. Okay, so they are asking us to verify whether point P is on the line capital L. Okay, well, you can check. Okay, so first of all, we know the parametric form of vector R or the line L is equals to x is equals to 1 plus 4 lambda, y is equals to 2 plus 5 lambda, and z is equals to 3 plus 6 lambda. Okay, since they have given that x is equals to 5, x is equals to 5, you can say 5 is equals to 1 plus 4 lambda. So in this case, lambda is equals to 1. Lambda is equals to 1. So for other coordinates also, lambda must be equals to 1. Okay, so shall we try? So we know this is the RHS for y is equals to 2 plus 5 lambda. Okay, we know the LHS is equals to y, which is equals to 7. Y that is given, and RHS is equals to 2 plus 5 lambda, and we know lambda is equals to 1 as they have given that x is equals to 5, so we found out that lambda is equals to 1, so it will be equals to 2 plus 5 into 1, so that is equals to 7. Since RHS and LHS are equal, y satisfy the equation. Okay, y equals to 7 satisfy the parametric equation for y. Similarly, you have to check for z also. So for z, 3 plus 6 lambda, LHS z is equals to 9. Okay, what about RHS? RHS is equals to 3 plus 6 lambda, and we know lambda is equals to 1. So 3 plus 6, which is equals to 9. Since RHS is equals to LHS, z equals to 9 also follows the parametric equation z equals to 3 plus 6 lambda. Therefore, point P must be a point on line L. Must be a point lying on line L. Okay, so this is how you can use parametric equations. Okay. This question is about the parametric equations. Okay, so let's try to solve this question. Yeah, in this question they are saying R is equals to minus 3, 9, 10 plus S into 6, 0, 2. And they are saying point P, which is 15, 9, C, lies on L1. We have to find C. Very easy. Okay. Let's try to solve this. Okay. So this is the equation, vector equation of the line L1. So you can say L1 is given by this specific equation. And we know P is 59C. So first of all, we will derive the parametric equations for L1. So for L1, parametric equations are, we can say x is equals to minus 3 plus s into 6. Okay. And y is equals to 9 plus s into 0. And z is equals to 10 plus s into 2. Okay. How did I arrive this? Well, we can break this down. R is equals to minus 3, 9, 10 plus, since we have s, we can say s into 6. This is scalar multiplication because s is a scalar value and r is a vector. So we can multiply, we can use the scalar multiplication application operation for this vector. So you'll get s into 0 and s into 2. And this will be equals to minus 3 plus 6s. And this and the j value will be 9 plus 0, 9 plus 0, and z value 10 plus 2s. So this is what we have come up with. Minus 3 plus 6s, y is equals to 9, and z is equals to 10 plus 2s. Now, for value p, or sorry, point p, the x value is 15, y value is 9, and the z value is c. Okay, so let's say when s is equals to lambda, okay, a specific value, when s is equals to, here we have the parametric value of s. When s is equals to lambda, let point p 15, 9, c. Okay, so p lies on L1. Now we are going to equate these things. So 15 is equals to minus 3 plus 6 lambda, and 9 is equals to 9. I'm using these equations, these three parametric equations. C is equals to 10 plus 2s, which means 10 plus 2 lambda. Why? We are assigning the value lambda to f. And when that is the value, the point P lies on L1. So we can say 6 lambda, we can find 6 lambda. 6 lambda is equals to 15 plus 3, 18. Lambda is equals to 3. And we can substitute lambda is equals to 3 in this equation. So in 3. So C will be equals to 10 plus 2 into 3, which is equals to 16. So this is how we have to find C. Okay. Now we will look at next question. In the next question, they are saying second line L2 is parallel to L1 and passes through 1, 2, 3. Okay, so this is the equation for L1. Okay, this is the equation for L1, and they are saying L2 is parallel to L1, which means we can say L1 is equals to, I don't know, KL2. Okay, this is equal to KL2. That's what it is given. So, sorry, we can't say L2 parallel to L1, we can't say that. We have to mention the direction vector. Okay, the direction vector are same. In this case, we have to say the direction vectors are same. So, the direction vector of L2, direction vector of L2 is equals to 6, 0, 2. And we have to find the position vector for L2. We have to find position vector of L2. So if we find that, the question is over. And they are saying L2 passes through 1, 2, 3. L2 passes through 1, 2, 3. Okay. So position vector can be 1, 2, 3. So the vector equation of L2 can be given as R is equals to 1, 2, 3 plus mu 602, where mu is a real number. This is how you have to do this parametric equation question.
Thanks for watching the 13th video in our vector series. If you found this explanation of parametric equations of the line helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.